All right, my name is David Dye. We're here at Schenck Job Corps. Today is April 19th, 2021. And today we're going to go over how to read a tape measure, okay? Why do you think it's important to accurately read a tape measure?
Because it's like for very dangerous jobs, it's like more important for those type of jobs.
Okay, so you got very important things that go on, such as, you talk about working on a nuclear site. Things have to be within a millwright's position in the 5/1000ths of an inch. If a motor is not accurately balanced, then it could cause it to rattle over time and become displaced, right? So it can mess up the motor. What else do you think it could also cause?
You gotta have like a precise cut.
Okay, precise cuts.
Yeah.
Doing trim work like you see in the classroom here. If it's not accurately cut, then you're also going to have gaps between your wood. So we got to make sure that we're accurately cutting. That way that we have no gaps in between our boards on the trim and things like that. It also makes a lot of difference when you're doing cutouts for houses. If your walls are not the same height all the way down, it can cause you to have waves. So when we get into this, what we're trying to do is make it easy for you to understand one part of that tape measure, and that's the inch. Because the inch is replicated every single time you get to a new inch. Does that make sense?
Yeah.
So when you're looking at a tape measure, you've got all these different inches that equal up to 12 inches, correct? Which makes a foot. But when you break it down, each inch is a replication of the one before it. Does that make sense? All right, so what we're going to do is we're going to go over one single inch so that we understand each part and the breakdown. Now, when we start, we're starting with 0, correct? Our end result is 1 inch. Does that make sense? So when we get to the end, we'll be at 1 inch. All right. On an inch, how many lines are there in between? Do we know?
16.
16. There's 16 marks between 0 and 1. Okay? So what does each one of those represent if it's a 16?
1/16.
1/16 for every single line. Got it? All right. So when we start with our first mark on the inch, what is that number?
So 1/16.
That's 1/16. Okay. What is our next mark?
Would be a 1/8 of an inch.
No. What's our next number? Where every line is equal to 16. See, 2/16, right? So our next mark is 2/16. Now, when we go to math class, we have to reduce, right? Everybody remember that from math class in high school? Okay, so let's think about that for a second. We have two rules when it comes to reducing within an inch, okay? It's called odd over even and even over even. Does that make sense?
Yeah.
All right. So when you have 1/16, is that odd over even or even over even?
That's all of these.
Odd over even. What are we going to do with that? Can you do anything with that?
No.
No, right? So when it's odd over even, we're going to leave it alone. Okay? Does that make sense?
Yeah.
So if it's odd over even, we're going to leave it alone. We ain't got to do nothing else with it. When we get to the next one, it says 2/16. Is that odd over even or even over even? Even over even. So what do we have to do? We got to reduce it, right? Okay. So those are our two rules that we got to keep up with. Now that we are to where we need to reduce, right? We need to think about something else. What do we reduce by? right? Well, in the inch, we only have 3 numbers we're gonna reduce by. Does that make sense? They are 2, 4, and 8. Okay? So, we always want to use, go ahead.
Why not 6?
It's just the inch. That's all we're worried about. Does that make sense? So right now, yes, there are thousands of numbers that you can reduce by, but the only 3 that we are worried about in the inch are these 3. 2, 4, and 8. Okay? So when we get to that first one that we're going to reduce at 2/16, which one of these numbers will go into both of the top, the numerator and the bottom denominator? 8 will go into 2?
2.
2. 8 can't go into 2, right? 2 can go into 8, but 8 can't go into 2, right? Okay, so when we get to this, we're going to use 2 for the first one. So 2 goes into 2 how many times? 1 time, right? 2 goes into 16 how many times? 8. There you go. So 2/16 is the same as 1/8. Does that make sense? All right. So what's our next line? How many 16ths? 3/16. Can we reduce it? There you go. What's the next one? 4/16. Can we reduce that? What can we reduce that by? 2, 4, or 8. You can do 2 or 4, right? Well, let's do 2 full. 2 first. So 2 goes into 4 how many times? Okay. How many times does 2 go into 8? I mean 16? 8 times. Now, is that even over even still? So we can still reduce it, correct? So what is it reduced again? What will go into 2 and 8? 2, right? So, how many times does 2 go into 2? 1 time. How many times does 2 go into 8? 4 times. So that's 1/4. Does that make sense? Alright, let's go to the next one. What's the next 16? 5/16. Is that odd over even or even over even? What's that mean? There you go. What's next? 6/16. What goes into that? 2 and 4 again, right? 2 goes into 6, how many times? 2 goes into 6? 3 times. I'm sorry. 2 goes into 16? 8 times. Alright. Can you reduce that? So we're going to the next one. What's the next one? 7/16. Can you reduce it? Nope. Going to the next one. What's next? 8/16. Alright. How many times what goes into 8 and 16? All 3 of them, right? So let's break this all the way down. Does 2 go into 8? How many times?
4.
Okay. Does 2 go into 16? 8 times. Does 4 go into 8?
2 times.
Does 4 go into 16?
4 times.
And then, what goes in, to 2 and 4? Let me put this back up here. How many times does 2 go into 2? 1. How many times does 2 go into 4?
2.
Twice. So our end result is half, right? So we're halfway across. Does that make sense? All right, what's our next line? 9/16. Does it reduce? Okay, so what's next? Does that reduce? What's it reduced by? 2, 4, 8.
All three.
2, 8 will go into 10?
One time.
Huh?
8, 1, 10.
We don't want no remainders. We want it even.
Also 4. 2 and 4.
Just 2, right? 2 goes into 10 how many times? 5 times. How many times does 2 go into 16? 8 times. So we're at 5/8 now. What's our next number?
11,
Alright, 11/16. Ooh. Does that reduce? There you go. What's the next one? 12/16. Does that reduce? Alright, what's the highest one that'll go in it? Out of the 3.
24.
Huh?
24.
2 and a 4 will go into it, but now that we know how to reduce all the way down, let's go to the highest one that will go into both of them.
So 4.
4, right? So 4 goes into 12.
3.
4 goes into 16.
4.
So we're at 3/4. What's the next 16?
13 and 16.
Gotta start writing a little smaller, don't we? So, does that reduce?
No.
No. What's next?
14.
14/16. Does that reduce?
Yep.
What's that reduce to?
2 and 8? Or 8?
Does 8 go into 14?
2 and 4. No.
No, it doesn't.
2 and the 4, right? So which one's higher? The 4.
4.
So how many times does 4 go? No, I'm sorry. 4 does not go to 14. 2, right? So the 2 goes into 14 how many times? 7. There you go. 2 goes into 16? 8. Alright, can we reduce that?
No.
Let's go to the next one. What's next? 15/16, right? Can that be reduced? Alright, now we're getting to 16/16. What is any whole number over a whole number that's the same equal to? Any number divided by itself equals 1, right?
Oh, so it's 1
So it's 1n. There's your n. Does that make sense? Does everybody understand how we got to 1 inch?
Yeah.
Looks good. All right, so what we're going to do now is we're going to go out in the shop. We're going to work on doing this in the shop, measuring out on a practice sheet that I've printed off for you. Cut it off.